Welcome to Archiversity online classes. In this lecture, I am going to explain you the concept of independent samples t-test. Along with that, I also explain you what are the assumptions required to run an independent samples t-test and how to frame the hypothesis and what is its importance and the context in which we use independent sample t-test. Instead of focusing on the formula of calculating independent sample t-test, I'll show you the IBM SPSS procedure to run independent samples t-test. Along with that, I'll also explain you the output of IBM SPSS statistics in detail. The independent sample t-test assess whether the means of two independent groups, that is, these groups are to be measured on a non-parametric, that is a categorical, in the sense using a nominal scale. What is that the independent sample t-test does is it assesses whether the means of two independent groups significantly differ on a quantitatively measured dependent variable. So when you're saying that a dependent variable, this need to be measured quantitatively. That means using a continuous scale. So to run a t-test, what is required is your independent variable to be measured on a nominal scale, whereas the dependent variable should be measured on a continuous scale. So when we say continuous scale, it may be a interval scale or it may be a ratio scale. Now the independent sample t-test, or also called as independent t-test, compares the means of two unrelated groups. So when we are saying that these two groups which are measured on a nominal scale need to be unrelated. Now, if the groups are related, then we go for a paired sample t-test. So to run an independent sample t-test, the groups need to be unrelated and measured on the same continuous dependent variable. The assumptions that we make are the independent variable should consist of two categorical independent groups. So independent groups means they are not related. Next is that the observations are independent. Let us say in a categorical variable, say you have a C1 and a C2, and if you have observations of different observations like observation 1, observation 2, observation 3, these need to be independent. And the third assumption is that there should not be no significant outliers. Sorry, the dependent variable should be normally distributed. Then when it comes to the homogeneity of variance, we make an assumption that the variance is homogeneous across the two groups. And if the variance is not homogeneous, then there is an other test to be performed in SPSS. The advantage of IBM SPSS is that when you run independent sample t-test, it will give you results for both. That is, when the assumption of a homogeneity is met and when the assumption of homogeneity is not met. I'll explain that also further. Now the hypothesis that we are going to frame in independent sample t-test is that the null hypothesis is two population means are equal. Two population means are equal. Whereas the alternative hypothesis is that the two population means are not equal. The two population means are not equal is an alternative hypothesis. So here when you are talking about M1, M2, that is a group 1 and group 2 respectively. Now coming back to the homogeneity of a variance. Now while running an independent sample t-test, we make an assumption that the variance should be homogeneous across the two variables. If not, then how is it we are going to check whether it is a homogeneous or not? For that purpose, we use the test called as a Levin's test. So SPSS will automatically give you the output for the Levin's test. Now using this Levin's test, we will find out whether the variances are homogeneous among the groups or not. Then how is it you are going to interpret Levin test is that if the test is statistically significant, then homogeneity of variance has been violated. So this is if statistically significant mean the two groups are not homogeneous, as we are saying that homogeneity of variance has been violated, so not homogeneous. If test is not statistically significant, then it is a homogeneous. Now how is it you are going to measure? As I told you, IBM SPSS will give you a result for the both. In the sense, when the homogeneity of variance is assumed and homogeneity of variance is not assumed. So these two will come up with example of a Levin's test of equality of variances. Now you don't need to worry about this. SPSS will automatically give you the result for equality of variances, and based on that you need to interpret the result, which test you have to follow. And now while running an SPSS test, first you have to look at for your assumptions. So normally we have two categories, are there or not, and they're independent or not. So this independency you will get from the random sampling or sample. Then you need to identify whether there are outliers in your data set or not. Then whether data is not normally distributed or not. Homogeneity of variance, automatically SPSS output will give you. Now I'll show you an example. Here we have a data. Now this data belongs to a public and private sector banks in India. Now your categorical variable, that is bank type, is the commercial banks. Then category is a nominal scale, and here you can look at the values. So here values you have two groups. One is a public group and second one is a private group. So one assumption of independent sample 2 tests is that there need to be two groups which are measured on a categorical scale, that is a nominal scale. So here we have two groups. One is a public group, public banks, and second one is a private banks, and these two are independent. Next, your dependent variable should be measured on a continuous scale. So here we have an interest. This is interest income as a proportion of a total income. So here we converted it into a ratio from the total income, what is proportion or a percentage of interest income, and listed for both the public sector banks and private sector banks. Now what is that we need to know here is that whether the mean interest income of a public sector banks are equal to mean income of a private sector banks. That is, we are trying to measure the mean interest income of public sector banks, comparing it with the mean interest income of a private sector banks. Are the same or there is any difference? First, to check the assumptions, that is outliers are there or not, and next is that whether the data is normally distributed or not, you need to go to analyze, and from analyze descriptive statistics, from descriptive statistics explore. So here in explore, choose the variable, that is interest income, send this to dependent list. Now go to statistics. Here select outliers, descriptives are already there, then also select the outliers, click continue, then click on a plots push button. So here you have a explore plots, select the box plots, because box plots will help you to identify the outliers, and uncheck descriptive and select a histogram here. Then select normality plots with tests. Click on a continue push button. You will be back to the explore window. Now click OK. Once you are done with the procedure, SPSS will give you an output document here. Now observe here, the mean statistics is 85.52. We look at the to look at whether the data is not normally distributed or normally distributed, we look at skewness values and kurtosis values. If skewness value and kurtosis value are in the range of plus or minus 1, then we say that the data is normally distributed. Here our skewness is minus 0.0 and minus 0.016 is a kurtosis. So these two are very close to your 0. So we can confidently say that the data is normally distributed. That is one. Second is you have a test of a normality here. There are two tests of normality. One is a Kolmogorov-Smirnov test and Shapiro-Wilk test. Both the tests are not statistically significant. So here if you look at the p-value 0.2, which is greater than 0.05, and Shapiro-Wilk test 0.49, which is also greater than 0.05. So both are statistically not significant, which indicates that the data is normally distributed. And you look at the histogram here. So now these three tests, that is a skewness, kurtosis, and your Kolmogorov-Smirnov test and Shapiro-Wilk test, all the three says that the data is normally distributed. So one assumption is met, and you can look at the QQ plot. So here on a diagonal line, normally all your observations should be very close to the diagonal line. So this is there except one observation. So normality condition is met. Next is outliers. So here is your box plot with your 25 percentile, 75 percentile and a median 50 percentile and your whiskers on both the sides, and we don't see any outliers here. Now these two assumptions are also met. Now if you look at here, so one is that it got a two categorical variables, that is done, and second is independent of observations, it's also done. There are no outliers, then data is normally distributed. So you can confidently run the independent samples t-test. To run an independent sample t-test, now click on analyze, then go to compare means. So from compare means, select independent samples t-test. So here you have a independent sample t-test and select the variable, that is your interest income. Send this to test variable. Then you have a groups here. Then choose the commercial bank which is on a nominal scale. Send this to grouping variable and here define a groups. So we define groups as a 1 for public sector and 2 for private. So group 1 and group 2. Then click continue and go to options. So options, confidence interval percentage is 95%. If you want to check it at a 99%, you can change this. Otherwise you can continue. Click continue push button. Then click OK. So here is the output of independent samples t-test. Now look at the interest income as a proportion of a total income. Public sector respondents are 18 observations and private sector 22, total are 40. Their mean values, standard deviations are given. Now here is the test result of independent sample t-test. First we look at Leven's test of equality of variances. So in case of Leven's test of equality of variances, if your F value is 4.9 and significance value is 0.03, which is less than 0.05 and indicates that the test is statistically significant. So when the test is statistically significant, it means that the variances of two groups are different. So in such scenario, you have to read this second row, that is equal variances not assumed. Now look at the t value here. It is 0.6, significant degrees of freedom is 36 and test value 5.47 and mean, standard error and confidence intervals. Now if you look at the significance value here, it is 0.547, which clearly indicates that there is no significant difference in mean returns of or average interest income of public sector banks and private sector banks. So we are retaining the null hypothesis here and concluding that there is no significant difference in mean interest income or average interest income of a public sector banks and average interest income of a private sector banks as a proportion of a total income. So this is what we are talking about, homogeneity of variance. Now here our output clearly indicates that the assumption of homogeneity is not met. That is the reason why we went for the interpreting the equal variance not assumed. If this test is statistically not significant, then we make an interpretation using the first row results. So this is how you need to make assumptions for your independent sample t-test, frame the hypothesis, then check the assumptions using explore function, then run the independent sample t-test and interpret the results based on whether equal variance is assumed or not. Thank you for listening to the lecture.